Hello everyone, welcome to my channel J Networks. In this video, we'll look at one of the most important services on the internet, that is DNS, Domain Name System or Domain Name Services. We use this service every day in our life without even realizing that we're using this service because wherever we type any web address, for example, google.com or yahoo.com in the browser, the first action that happens on our laptop or smartphone, Android phone or iPhone is a DNS query. A PC can use DNS to discover the IP address that corresponds to a particular host name, or host name could be any web server name. Just I have mentioned Google or Yahoo. URI typically lists the name of the server, a name that can be used to dynamically learn the IP address used by the same server. Before getting deeper into the concept of DNS, let us see a topic called as URI, Uniform Resource Locator or Indicator. The general term we use instead of URI is URL, but the current use is called the URI. For example, any website www.google.com. This whole part, including the HTTP, that is protocol, this is called as URI. So I am telling this to understand the initial steps of DNS. As we type this particular URI in the browser doesn't know where to send the packets to. It only knows the user is requesting for a web server's connection, and the web server's connection is for google.com. So the PC doesn't know where to route the packets for google.com. So initially, as soon as we type www.google.com in the browser, the first step that happens in the PC is DNS resolution. The server sends a DNS query. The DNS query runs on protocol UDP and port number 53. By default, all of our PCs are configured on public DNS servers. The public DNS servers most and well known are 4.4.4.4 and 8.8.8.8. There are other public servers which are not much used, or we can have our own private DNS server. So as soon as our PC queries to this DNS server asking for, hey, I need to go to google.com, and what is the IP address of Google? This DNS servers respond with the IP address. Let us assume the IP address is 169.72.13.14. Sorry, this should not be an IP address. This should be, let us assume this is 229. 169 is a private IP address range. So let us assume this is the IP address given by the DNS server to this particular PC. This PC then finds a default gateway that is configured on this PC, and this default gateway means the traffic or the unknown networks which the traffic that is to be sent from this PC that will go to the default gateway. We'll discuss about the default gateways and routing in detail in the upcoming networking videos. But for now, try to understand that the traffic would be sent to this default gateway. The default gateway could be the router, the black colored router box given to you by your ISP, and this ISP would have connections to all the routers in the internet, and then it would send to the Google server, and Google server will again respond to this router, and this router will send the information to the PC, and we would see a web page on our browser. So let us see with another example here. In this example, we'll use a Cisco website. In this, the user is trying to go to a Cisco portal called Cisco Learning Network. As soon as the user types this URI, cisco.com/go/learning network, the client, this is the user PC that would send a DNS query. So this is the name resolution request, name resolution request given by this server to the DNS server. Let us assume this is a public DNS server 192.168.7.1, and the DNS packet would have this information. The source would be the IP address of the PC 64.100.1.1, and the destination would be the DNS server's destination IP address 192.168.7.1, and the UDP header. The UDP header corresponds to the DNS query would be the source port would be a random port number 49161, and the destination port would be UDP 53, and the DNS request would be what is the IP address of cisco.com. It is straight away asking the IP address of the server cisco.com, and this is the first packet. In the second packet, the DNS server responds with the source IP address as its own IP address 192.168.7.1, and the destination as 64.100.1.1, and the source port would be 53 because it is responding on the DNS service. So this is 53, and the destination port would be 49161. So here again the concept of multiplexing comes into picture. So if you have any questions regarding multiplexing, please go to my other videos about TCP multiplexing so you can understand clearly. So the port number 149161 is the destination port here, and the DNS request says that the IP address of Cisco is 198.133.219.25. Now the client has got the IP address of the Cisco. Now the client will directly create a packet and send it to its default gateway. For example, if the client is sitting in a home or a home office, it will send a packet to its default gateway, that is the router given by the ISP. And this will have all the information about how to route the packet to this particular IP address 198.133.219.25. This is the packet here. This is the packet that is created. The first packet. So the source address is 64.100.1.1, and the destination would be the IP address of Cisco's web server, that is 198.133.219.25. The source port would be a random port 49172, and the destination port would be port number 80, and this is a SYN packet. So the first packet, SYN packet, goes to this server, and the server responds back with ACK, and again the client responds back with, sorry, the server responds back with SYNAC and the client responds back with ACK. So there is a three-way handshake happens. This whole process takes less than a second, a few milliseconds to happen. The client sending a DNS query and the DNS server responding back to the client with the IP address, and then the client creates a packet with the destination IP address and sends it to its default gateway. So this happens in less than a second. So for example, if the client again wants to cisco.com after a few days, so this whole process, will it happen again? No, it doesn't happen. The client will do a cache called as DNS cache. The DNS cache is present in all our PCs and Android and iPhones. This DNA cache, we can view it using a few specified commands. We can remove this DNS cache. So we can see whatever the DNS information is present in the PC. If there is a DNS cache already present for this particular Cisco in our PC, this action would be faster. The faster action we cannot notice because that happens in a few milliseconds or few hundreds of seconds. Alright, so this is the process that happens for a normal home user. Whereas an enterprise user, there will be something called as local DNS server. Most of the enterprises they maintain their own DNS server inside their data centers. These servers inside their data centers, they have their own DNS entries. For example, some hostname, some hostname and its corresponding IP address, and second hostname and its corresponding IP address. If these entries are not present, for example, if a user inside an enterprise or a company sitting inside a company desk types some example website, and then if that information is not present in the local DNS, the process is different. We'll discuss that process in the next uh, figure. Okay, all right, let me clear out this figure here so that I'll explain the concept of recursive DNS. All right, in the case of enterprise DNS, the enterprise DNS server acts as a recursive DNS server. It would be sending repeated DNS messages in an effort to identify the authoritative DNS server. So what happens in this? This is the client, client PC. This client sends a DNS request for a website. For example, let us take a cisco.com. This asks for cisco.com's address to this enterprise DNS server. So this is the first message here. And then the recursive enterprise DNS server does not know the answer at. That means that this enterprise DNS server does not know the IP address of the cisco.com, but it does not reject the client's DNS request. Instead, it follows a repetitive recursive process shown in these steps. It sends a repetitive query in these steps 2, 3, and 4. So there is something called as root DNS.com TLD DNS. That means TLD means top level domain, and authoritative DNS. Beginning with the DNS request sent to root DNS server, the root DNS server does not supply the IP address of cisco.com, but it supplies the IP address of another DNS server, one responsible for the .com top level domain. So this root DNS server, when this enterprise DNS server queries for cisco.com's IP address, it does not provide the cisco.com IP address. Instead, it provides the IP address of .com top level domain DNS server's IP address. So in this message, it gets the IP address of top level domain. Then the recursive enterprise DNS server sends the next DNS request to the DNS server learned at the previous step. So the enterprise DNS server sends a query, DNS query about the cisco.com to this .com top level DNS server. This DNS server also does not know the address of cisco.com, but it knows the DNS server that should be authoritative DNS server for domain cisco.com. So it supplies the IP address of this authoritative DNS server's IP address. In the next packet, the enterprise DNS server again sends a query to the authoritative DNS server asking for the IP address of cisco.com. This DNS server is the authoritative for cisco.com, and this supplies the IP address. Then the enterprise DNS server returns a DNS reply back to the client supplying the IP address of cisco.com. So we do not notice any delay or any length of time in all the process because it takes less than a second. All this process takes less than a second if all the network connectivity is fine between these DNS servers. So In this video, to summarize, we have learned about client to uh, public DNS servers in the case of a home PC to a public DNS server in a home network, and the second one is in an enterprise network how the DNS queries happens. So this is a brief outline of how the DNS requests happen. In a next video, I'll explain with the packet level. I'll explain about how the DNS packet would be embedded into the IP packet and what are the fields in the DNS. And the DNS is a very complicated and very huge topic. So this is an outflow for beginners who just want to understand how DNS happens and what is the DNS. If you like this video, please like and share this video, and also try to comment if you have any questions. Please subscribe to my channel. Thank you very much for watching.